Let's consider how scalable capacity of cloud-based applications can improve operational efficiency. Rapid elasticity and scalability means that the resources allocated to an application can be adjusted to grow or shrink online capacity quickly. Measured service of cloud computing means that the organization operating a cloud-based application pays only for the resources that they use. Combining rapid elasticity and scalability with both measured service for cloud resources and scalable application capacity management can reduce wasteful service overproduction, which squanders cloud resources that the organization ultimately pays for. Let's consider online application capacity as being logically composed of 4 slices. Core online capacity serves cyclical user demand, like the 15-minute average user demand between 9 a.m. and 9:15 a.m. on Monday morning. The variance capacity slice serves random variations in user demand, like the busiest moments, above cyclical user demand, which is served by core capacity. Reserve or spare online capacity mitigates risks of failure, forecasting errors, serves lead time demand, and so on. Reserve capacity is like the spare tire in your automobile. It's not actually necessary to carry a spare tire to drive your car, but if you get a flat tire, then without a spare tire, you will have an unacceptable service interruption. An organization's policy and operational capabilities determine how much reserve online application capacity is appropriate to balance the organization's user service quality targets against their appetite for cost savings and tolerance for business risk. The sum of core capacity, variance capacity, and reserve capacity is the target online capacity, which is necessary to serve user demand with acceptable service quality and business risk. If online application capacity falls below target online capacity, then there is elevated risk of some or all users experiencing unacceptable service quality. Online application capacity above target is surplus to what is required to serve actual user demand with acceptable quality and business risk. Surplus capacity is wasteful, like stuffing the trunk of your car with 2 or 3 additional spare tires, because that surplus capacity consumes resources but doesn't materially improve quality or reduce risk. Reducing surplus online capacity reduces consumption of virtual compute resources, which reduces cost to the organization. Consider a typical application with high user demand when most people are awake and low demand when most people are sleeping. Imagine the organization uses a simple daily capacity management scheme. With low off-peak online application capacity from 11 p.m. to 7 a.m., and much higher peak online application capacity from 7 a.m. to 11 p.m. to comfortably serve daily user demand with acceptable service quality and business risk. Online application capacity above target online capacity is surplus. Resources consumed producing surplus application capacity are wasted. The double line shows a more aggressive scalable capacity management scheme that tracks actual user demand more closely. More aggressive scalable capacity management dramatically reduces surplus online application capacity and hence the organization's cost of capacity waste. There are 5 fundamental scalable capacity management schemes. The most mature is Level 5 real-time demand capacity management, which aggressively tracks real-time patterns of user demand. Level 4 daily demand uses 2 regular capacity change actions per day to toggle between peak and off-peak periods. Level 3 weekly demand schemes adjust online capacity every week or so. Level 2 seasonal demand schemes adjust online application capacity every few months, or perhaps only once or twice a year. Level 1 lifecycle demand schemes set application capacity at day 1 for the level of peak demand forecast across the product's lifecycle. Traditionally deployed applications were often configured for peak lifecycle demand. Higher scalable capacity maturity levels reduce wasteful surplus online application capacity, which reduces consumption of cloud resources and cost to the organization. Mature organizations strive for optimal scalable capacity management, which balances the organization's incremental savings from reducing surplus application capacity through more aggressive capacity management against the incremental costs of that more aggressive scalable capacity management. In short, the scalable capacity lever improves efficiency of operating cloud-based application services by reducing wasteful surplus online application capacity, which accrues resource costs without materially improving service quality or reducing business risk. If you are interested in discussing how these efficiency concepts could bring value to your organization, then please get in touch with Matt Dove from Nokia's Cloud Transformation Consulting business. I'm Eric Bauer. Thank you for watching.